Hello guys, today we are going to study a chapter real numbers. To know about real numbers, first we know about natural numbers, whole numbers, integer, rational number, irrational numbers. Natural numbers. Our counting numbers started from 1, 2, 3 and so on is called natural numbers. Whenever 0 included in the natural number, it will becomes whole numbers. All the whole numbers with the negatives of natural numbers, the set look like that. It is called integer 0, plus minus 1, plus minus 2 and so on. Whenever a number is in the form of p upon q, where q is not equals to 0, is called rational numbers. And if we can't write a number in the form of p upon q, it will become irrational number. The set of natural numbers, whole the set of natural number is inside the set of whole number. That means set of whole numbers contains set of natural numbers. Set of integer contains set of whole numbers. That means all the whole numbers are integers. Similarly, all the integers are our rational numbers. All the integers are our rational numbers. When rational and irrational numbers, that means set of rational and irrational number is known as real number. Set of rational and irrational number is known as real number. In a simple language, we can say that a number that can be represented on a line is called a real number. That means every real number we can represent on a number line. Every real number we can represent on a real line. In a simple language, we can say that a real number can be represented on a number line. In our previous classes, we know how to represent a natural number, whole number, integer, rational number as well as irrational number on a number line. That means all the number can be represented on a number line and all these numbers are real numbers. In the whole chapter, we studied about real numbers. First, we need to know about two very important properties of positive integer. These properties are, first one is equality division lemma. And second one is fundamental theorem of arithmetic. Fundamental theorem of arithmetic. First we started with equality division lemma. Now we started with equality division lemma. If two positive integers a and b, then there exist two unique integers q and r such that which satisfying the property A is equals to VQ plus R, where R is greater than or equal to 0 and less than to B. It is nothing, it is just like your childhood concept. Dividend is equals to divisor into quotient plus remainder. By using this lemma, here we can find SCF of two numbers. Here we take one question. Use equivalent division algorithm to find the SCF of 135 and 225 and 225. In 135 and 225, we first check which is a smaller number. We know the smaller number is 135. So our divisor is 135 now, and 225 is our dividend. That means our smallest number will become our divisor. Now we started the procedure. 135 is our divisor and 225 is our dividend. 135, here quotient is 1 and it will become 135. The subtraction of these is 90. Now our remainder is not 0, so we can't stop. Now in the next step, 90 and 135. 90 is smaller than 135, so 90 is our divisor now and 135 is our dividend now. Once again 1, 90, now remaining 5 and 45. Now remainder is again not 0, that is 45. Now next process we follow between 90 and 45. The smallest number between them is 45, so smaller 45 is our divisor and 90 is our dividend. $90 and remainder is 0. Whenever our remainder is 0, we stopped. Last divisor is 45. So our SCF of 135 and 225 is equals to 45. So by this manner we can find the SCF of two positive integers by using equivalent division algorithm. We can also use prime factorization, but here we can't use because in the question it is clearly asked use equivalent division. So we have to do the procedure like this. So in this manner we can find SCF of two positive integers, two number.